The biggest controversy in human evolution is no longer whether we interbred with Neanderthals. It is not whether Denisovans existed. The true fault line now runs much deeper. It cuts through the very definition of our species. The question is stark. When and where did Homo sapiens originate? And depending on which evidence you prioritize, morphology, nuclear DNA, mitochondrial DNA, Y chromosomes, or cladistic reconstructions, you can land anywhere between 300,000 years ago and more than 1 million years ago. That is not a minor academic disagreement. That is a tectonic fracture in the foundation of human evolutionary theory. The standard narrative used to be relatively simple. Modern humans evolved in Africa roughly 200,000 to 300,000 years ago. Fossils like Jebel Irhoud in Morocco at about 315,000 years were folded into a model of African origin followed by dispersal. Clean lines, clean categories, clean migration arrows. But the lines are no longer clean. The recent Yunxian cranial analysis throws gasoline on the fire. In that phylogenetic reconstruction, the origin of the Homo sapiens clade is estimated at approximately 1.02 million years ago. Not 300,000, not 200,000, 1 million. If that reconstruction is correct, then the sapiens lineage, defined cladistically as a branch of a larger Eurasian radiation, has roots deep in the early to middle Pleistocene. That is not a trivial revision. That is a rewriting of the birth certificate of our species. Now add the Denisova 25 genome into the equation. In this model, the modern human lineage, Homo sapiens, is estimated to split roughly 825,000 and 694,000 years ago, based on nuclear branch shortening. Its position in genomic trees suggests complex population structure, including deep splits and gene flow among lineages that would later give rise to Neanderthals, Denisovans, and modern humans. If genetic divergence between these populations reaches back toward 800,000 years or more, then the last common ancestor of sapiens and these Eurasian archaic populations must be older still. However, supporters of the 1 million year age of Homo sapiens say that interbreeding means that the true split is closer to 1 million years ago. Genetics is not whispering, it is shouting. The divergence between our lineage and other Eurasian hominids predates 300,000 years by a massive margin. If the sapiens clade truly split from its Eurasian sister lineages around 1 million years ago, the idea that this lineage then marched en masse into Africa, neatly contained itself there for nearly 1 million years, and patiently waited like laboratory rats for a dramatic late Pleistocene release, makes little evolutionary sense. Lineages do not behave like synchronized caravans that relocate once and freeze in place for geological epochs. They fragment, expand, contract, interbreed, and respond dynamically to shifting climates and ecological corridors. To imagine a fully separated sapiens branch quietly isolating itself inside Africa, only to suddenly erupt outward in a coordinated dispersal, is to impose a modern narrative of confinement and breakout onto a Pleistocene world defined by fluid population structure. Evolutionary history is rarely that tidy, and the deep divergence signals in both morphology and genetics argue for a far more complex, geographically entangled story than a single mass migration followed by prolonged stasis. And then there is Jebel Irhoud. For many, Irhoud at 315,000 years is the oldest secure Homo sapiens fossil. It shows a mosaic, modern-looking face, elongated archaic brain case. It has been framed as early sapiens, but not everyone accepts that classification. Critics argue that calling Irhoud Homo sapiens stretches the term beyond coherence. The morphology is transitional. The cranial vault is not globular in the way later sapiens' skulls are. The brain shape appears more archaic. Some researchers openly state that labeling these remains as sapiens expands the species definition to accommodate fossils that would previously have been classified differently. So what counts as the birth of Homo sapiens? Is it the appearance of fully globular crania around 100,000 years ago? Is it Irhoud at 315,000 years with its partial modern features? Is it the cladistic split at roughly 1 million years ago, when a lineage began that would eventually produce modern humans? Or is it the 800,000-year genomic divergence state inferred from DNA comparisons, suggesting that the Sapiens branch separated from sister lineages far earlier than our first unambiguous fossils? This is where the debate turns nuclear. If you define Homo sapiens morphologically, you anchor the species to particular anatomical criteria: a globular brain case, reduced brow ridges, specific facial retraction patterns. Under that view, Irhoud is borderline, and earlier fossils are excluded. The species becomes a relatively recent African emergence. If you define Homo sapiens as a clade, meaning a lineage descending from a specific common ancestor, then the origin of sapiens is the moment that lineage splits from its sister group. Under that logic, if the Yunxian reconstruction is correct, the sapiens clade originates over 1 million years ago. Everything downstream of that split belongs in a phylogenetic sense to the sapiens lineage, even if morphology lags behind. And if you define Homo sapiens genetically, by divergence times inferred from nuclear DNA, then the origin is pushed back to wherever the genomic split occurred. Denisova 25 and related data suggest deep population structure well before 600,000 years ago. That forces the sapiens branch to be ancient. These definitions are not interchangeable. They produce radically different origin stories. Here is the uncomfortable implication. Multiple independent lines of evidence, cladistic morphology, nuclear genomic divergence, and ancient Eurasian fossils converge on the idea that the sapiens lineage is far older than the traditional 300,000-year narrative. And that raises a question few are willing to confront directly. Where was this lineage located? The standard model assumes Africa as the homeland, but if the sapiens clade split from its sister lineage over 1 million years ago, and if Neanderthals and Denisovans were Eurasian, and if the Yunxian and Harbin material cluster within broader Eurasian radiations, then the center of gravity begins to shift. Under the conventional model, Homo heidelbergensis, or related African forms, gave rise to Homo sapiens around 300,000 years ago. Yet the phylogenetic reconstructions in the Yunxian study position the sapiens clade alongside Eurasian forms, diverging in a pattern that does not cleanly isolate Africa as the sole cradle. Genetics complicates this further. Deep splits between African and Eurasian populations sometimes predate the supposed emergence of sapiens in Africa. Denisovan-related ancestry, Neanderthal introgression, and super-archaic signals in both African and non-African genomes reveal a web of population structure across Eurasia and Africa stretching back hundreds of thousands of years. The tidy narrative of a small African population evolving in isolation and then bursting outward collapses under the weight of that complexity. The metaphor of a single exodus of a pure African population leaving a bounded homeland and colonizing Eurasia is increasingly strained. The genetic record instead suggests long-standing interconnected populations with episodic gene flow. If the sapiens clade began around 1 million years ago, it did not sit passively in one geographic corner for 900,000 years waiting for a dramatic escape. That is not plausible. Evolutionary lineages do not remain caged and static for nearly 1 million years, and then suddenly surge outward in a coordinated dispersal. Populations move, they expand, they contract, they interbreed, they fragment, they reassemble. The idea that the sapiens lineage originated in Africa, remained geographically confined for nearly 1 million years, and then emigrated in a single decisive wave requires an extraordinary degree of ecological stasis and geographic isolation that is difficult to reconcile with what we know of Pleistocene climate dynamics. Climate oscillated dramatically across the last 1 million years. Green Sahara phases opened corridors. Levantine regions fluctuated between humid and arid. Eurasia was not a monolithic barrier. It was a mosaic of shifting habitable zones. Hominin populations moved in response to these changes repeatedly. If the sapiens clade diverged around 1 million years ago, the most parsimonious explanation is that its early members were already part of a broader Afro-Eurasian network. The clade may not have been geographically restricted in the way traditional models assume. This does not require denying Africa's central importance. Africa was unquestionably a major arena of human evolution. But the evidence increasingly undermines the notion of Africa as an isolated incubator from which a fully formed species later escaped. The controversy over Irhoud illustrates this tension perfectly. For those invested in an African origin around 300,000 years ago, Irhoud is embraced as the earliest sapiens fossil. Its mosaic anatomy becomes evidence of early diversity within Africa. But for critics, calling Irhoud sapiens is a definitional maneuver designed to preserve the African origin narrative. If Irhoud is not sapiens, then the earliest clear sapiens fossils may be younger, and the clade's deeper origin lies elsewhere. Meanwhile, genomic data from Denisova 25 and related specimens show that Neanderthal Denisovan splits and Denisovan modern splits reach back far earlier than previously assumed. These genetic branch lengths are not compatible with a shallow 300,000-year-old origin of the sapiens lineage. So which marker defines the birth of our species, the morphological threshold, the cladistic split, the genomic divergence? The uncomfortable truth is that the answer depends on what one means by Homo sapiens. If Homo sapiens is defined as the population with fully modern cranial globularity and behavioral complexity seen in the late Pleistocene, then the origin is relatively recent and African-centered. If Homo sapiens is defined as a lineage, a clade, that split from its sister branch over 1 million years ago, then the origin is far deeper and geographically broader. If Homo sapiens is defined genetically as the lineage leading to modern humans, then the divergence from sister groups predates the earliest unambiguous fossils by hundreds of thousands of years. The camps form around these definitions. Morphologists, geneticists, and cladists can look at the same data and draw different conclusions because they are using different criteria for species identity. But here is the critical point. Multiple independent datasets converge on deep time. The Yunxian analysis pushes the sapiens clade to approximately 1.02 million years ago. Denisova 25 suggests population structure and divergence deep into the Middle Pleistocene, with roots extending toward 800,000 years or more. Neanderthal modern divergence estimates frequently fall between 500,000 and 800,000 years ago, implying that the common ancestor must be older still. Even African fossils older than 300,000 years show variability that does not fit a simple linear progression. The weight of evidence suggests that Homo sapiens did not suddenly crystallize in a single geographic pocket at 300,000 years ago. Instead, what emerges is a picture of a widespread Afro-Eurasian metapopulation in which lineages diverged, reconnected and hybridized over hundreds of thousands of years. The sapiens clade may have originated within that broader network, rather than within a single isolated African basin. The notion that a pristine African population evolved in isolation and then migrated outward, holding hands in a singular expansion, is increasingly difficult to reconcile with genomic and fossil complexity. Evolution is messy. Populations are structured, boundaries blur. The real controversy is not simply about dates, it is about definitions and geography. If the sapiens clade began around 1 million years ago, then Africa was part of a larger evolutionary theatre, not an isolated stage. If Denisovan and Neanderthal divergences are that deep, then the ancestral population must have been widespread before those splits. If Irhoud is not fully sapiens, then the African fossil record becomes less tidy. And if Irhoud is sapiens, then the species must be defined broadly enough to encompass considerable morphological variation, blurring the line between archaic and modern. The debate is not going away. New fossils will continue to emerge. Ancient DNA from deeper time, perhaps from Middle Pleistocene Africa, could transform the landscape again. Improved morphological modelling may refine cladistic relationships. But one conclusion is unavoidable. The birth of Homo sapiens is not a simple single moment at 300,000 years ago in one corner of Africa. It is a deep, branching, geographically complex process extending back toward 1 million years ago, involving populations across Africa and Eurasia. Whether one calls that clade Homo sapiens from its split, or reserves the name for later morphological expressions, is partly a philosophical decision. The evidence itself is forcing a reckoning. The origin of our species is older than many thought. The geography is broader than once imagined, and the clean, linear story has fractured into a mosaic. That is the real controversy. Thanks for watching.